Everything fails all the time. Well, it's not that I'm an overly pessimistic person, but when it comes to designing architecture for a highly available, scalable, and a resilient database system, I would like to believe that everything does fail all the time. And my job as an architect is that when something like that happens, how to get things up and running with minimal damage and as quickly as possible. Welcome to AWS Summit. I am Anuja Malik. I'm the Database Specialist Solutions Architect for AWS. I'm very happy to talk about global databases today and share all about the use cases, the advantages, and the features of global database. So here is the agenda for this session. We will have a quick refresher on Aurora for those of you who are new to Aurora. From my experience, out of the many features of Aurora, global databases is quite becoming the one that is attracting a lot of customers to adopt Aurora. And we'll find out why it is so critical. Then we will cover the fundamentals of global database and its key features. We will also cover the managed RPO and managed planned failover, which are the newly released features of global databases. We will end with a demo where you will get to see global databases in action. So let's get to it. All right, so couple of things about Aurora that makes it different from the rest and that qualifies it as a truly cloud-native database. Aurora is a high throughput system, and what this means is that by using the scale-out distributed architecture, we have separated the compute and the storage layer of the database engine. The compute layer still does the transactions and the query processing and the caching, but the storage engine is really what is specially designed for the Aurora system. The storage volumes of your Aurora database is striped across the storage nodes, which are distributed over 3 availability zones. So Aurora maintains 6 copies of your data, 2 in each of the 3 availability zones, and that protects you against the availability zone's failure. Many of you have probably heard of the quorum that we utilize for Aurora, and which basically says that we need 4 acknowledgements to do a write commit on the primary, and we need 3 acknowledgements to do a read commit. Another thing that is unique and different about Aurora is that Aurora backups happen continuously. So there is no backup window, there is no performance penalty during the backup process, which many of our customers worry about with other database engines. The storage node continuously writes snapshots of 10 gigabytes of storage into S3 along with the logs. So in the event if you need to restore from the backup process, the hundreds of storage nodes in the storage layer can simultaneously access S3 at the same time and apply the logs at the same time. So this allows you for the fastest restore time. With Aurora, you can have up to 15 copies of read replicas across different availability zones within a single region, of course. And these read replicas can be promoted to primary when your writer or your primary instance goes down. However, what is different about Aurora replicas is that first of all, they are used for read scaling because they are fully dedicated to the read operations on your cluster volume. But as I was saying, the unique thing about Aurora replicas is that they access the same underlying storage as your primary. There is no separate duplicate storage layer for your replicas. They all go access to the same primary storage layer that is used by primary. All right, so let's switch gears a little bit. We have talked about the high availability and fault tolerance of Aurora database within a single region. But how do you achieve all of that across a region, across multiple regions for that matter? And that's where global databases come into picture. Even before global databases, I want to call out, is that even before global databases, customers could potentially replicate data to a remote region. However, they would have to go down the path of logical replication by using binlog in MySQL or pglogical in Aurora Postgres. And in this case, customers were responsible for implementing it. They were responsible for setting it up. They were responsible for monitoring and maintaining the latency requirements. So with global databases, we are really trying to meet 2 major requirements. The primary one is disaster recovery, to help our customers protect against regional outages. with minimal data loss and with minimal failover time. So let's say if they do have an outage, and by an outage, I don't necessarily mean that an entire AWS region going down, but realistically speaking, an outage could be, let's say, a network issue in your VPC. It could be a performance issue in your primary region, or it could be that you implemented a change in your application layer and that has caused a bug, causing all your application to go down. So for whatever reasons, you need to fail over to the copy of another, copy of your database to another region. And you don't want to lose data, of course, and you want it to happen quickly. So that's the primary design goal for the global databases. And we'll see how it works. It's also designed to help with geo-distributed reads, to help our customers process read traffic which is closer to their end users. By maintaining read-only copies of your database in different regions, you are lowering the latency of read-only workloads for your remote users. All right, so let's take a look at the first use case, that is a disaster recovery. When you have a natural disaster or any kind of regional availability issue, as I was referring to earlier, Global Database distributes your data and replicates your data across multiple different regions, so that you can have remote readers that can be promoted quickly for faster disaster recovery. In this example, you can see that we have a primary instance, which is a writer and reader in the US East region, and using Global Database, we are replicating to EU West. So in this case, if US East goes down, we can switch to EU West and continue running our operations from EU West. One thing to call out here, and it happens quite a lot, is that when we talk about disaster recovery, we need to plan disaster recovery for the entire stack. Very often people over-index disaster recovery on databases, but simply failing over your database to another node is not going to be enough when the actual disaster strikes. You need to ensure that all the components of your application are also configured to operate from this remote region. What's also important to note here is that when you create a read replica for Aurora within a single region, it is all synchronous replication. So the primary node waits for at least 4 storage nodes to acknowledge before it moves forward. So it's completely synchronous and there is no risk of data loss. Whereas the global databases implement a different replication technology, and we'll find out about that. However, between the regions, we have larger latencies. So to make it clear, the read replicas are a fit for high availability. However, global databases are meant for disaster recovery, where you are prepared to incur some loss. Generally, we are not that far behind. And again, we will be looking at the latency, but the important thing is that when a disaster happens, if you have to make a choice that do I want to bring up this region as a primary and continue running my workload, you are fully accepting that there might be some data missing. The RPO, the recovery point objective, is not 0 with global databases. And that's an important distinction from Aurora read replicas. Now, for the second use case, you can also use these replicas as read-only database for your remote users who will have lower latency by reading from a source which is closer to their geolocation. So in this case, again, we have the primary in US East, but we also have readers in the US West, EU West, and AP Southeast. And the benefit here is that A, I can improve the performance of my read-only workloads for my remote users, and B, I can also separate the reads and writes for my primary instance so that my writer has more bandwidth and therefore more resources and therefore better performance for my writer node. So this is more of a performance use case versus the disaster recovery use case. And as I said before, even though all of it was possible even before global databases, but the customers were responsible to create their own solution for this cross-region replication. With global database, you get these capabilities out of the box at the click of the mouse with minimal operational overhead. All right, so let's say that we have a primary in the Ohio region and the application is running against that primary. Using global databases, we have replicas in the Oregon as well as in the Northern Virginia and Ireland region as well. So A couple of facts about global databases. You can replicate your database to up to 5 secondary regions. And then, of course, you have the first one as your primary region. So you can have up to 6 regions in a global database. And every region, in turn, can have up to 15 read replicas. So that's why 15 multiplied by 6, you can have up to 90 readers within a global database spread across 6 regions. So you can have a really huge read-only farm for your application across the globe. And generally, you will have less than 1 second of cross-region lag. Although it will vary with your workload, it will also vary with the region that you choose and the distances, but typically we have seen a lag of less than 1 second. So the RPO, the recovery point objective, is in the range of 1 second. When it comes to the RTO, the recovery time objective, that is the time needed to cut over your secondary to make it primary when the disaster happened, that's generally within a minute. If you compare it to the RTO of current implementations of disaster recovery, for example, trying to restore from the backups, which is the most common one, that will generally take much more time. And therefore, customers are really pleased with the RTO of 1 minute with global databases. Now, what about the performance? A global database supports very high throughput, which is generally a bottleneck and a cause of pain and latency when you think of any replication technology across any database engine. With global databases, it supports up to 150,000 writes per second with very negligible performance impact. And we'll see that in the next slide, how global databases make it work. All right, so how does it really work? So the way Aurora works, the writers are sending log records to the storage engine. And this storage engine has its own resources. It operates independently from the database engine, and it is decoupled with the database engine. An Aurora cluster in a single region can have up to 15 read replicas, and those read replicas also consume those same log records. They consume those log records to keep their local buffer caches consistent and as close as possible to the actual writer. And therefore, as a result, for the Aurora in-region replicas, we see a replica lag of typically in milliseconds. It's 10, 20, 30 milliseconds. Now, the way Aurora Global Database works, in the storage layer, we have an additional component for outbound replication. The primary or the source region will have an outbound replication, and the secondary or the target region has a corresponding inbound replication component. Now, these set of agents are basically microservices that are continuously communicating with each other, where the outbound replication agent receives the same log records that all the readers inside the primary region are receiving. And it sends those log records across inbound replication agent inside the secondary regions. And then on the secondary side, the replication agent just acts as a primary. So it sends the log records to all the storage nodes, and it sends it to all the read replicas so that they can update their buffer pool pages just as the read replicas in your primary region. Now, you also notice that there is Amazon S3 in this picture, right? So with global databases, you can now have separate backups on your secondary region, including the point-in-time recovery of up to 35 days, and you can do separate snapshots. So yeah, one of the biggest demand from customers was that the ability to do cross-regions backups, which is now possible as part of global databases. So with that information, let's talk about performance one more time, right? Like I mentioned before, that we can have up to 150,000 writes per second. And here we see the comparison between logical cross-region replication, which you see on the left side, versus the physical replication, and that's what the global database is based on. On the right side, the x-axis is where we are measuring the latency, and the y-axis is the queries per second. Now, as you can see that as we increase the queries per second, the lag on the secondary y-axis keeps going up. And when we got up to close to 50,000 queries per second, there was approximately 10 minutes worth of replica lag. That means 10 minutes worth of data loss in case of a disaster. And that also means that the reporting workload on your remote regions will have stale data by 10 minutes. For some of the high throughput applications, such as financial applications, 10 minutes of data loss could cause a havoc, and it's just not acceptable. So if we go on the right side and look at the global database, you can see that we can take our queries per second to about 200,000 writes per second. However, the replica lag always stays below 1 second here. So going back to the fundamentals, inherently the way Aurora Storage is designed, it allows us to provide a high throughput, a high performance database without sacrificing availability and durability. And what we are trying to do with global databases is the key to that same goal, but we are increasing the availability and resiliency beyond the single region into a global infrastructure. All right, so to sum up the key features of global database, it is a physical storage level replication that can be used for faster disaster recovery in secondary regions. You can also use it for cross-region migrations and low latency read workloads. It is compatible with MySQL 5.6 and 5.7, and it is also compatible with PostgreSQL of 10.14, 11.9, and 12.4. So I want to talk about some of the newly released features of global databases, and one of them is Managed RPO. Managed RPO is designed to let you control how far you're willing to let your secondary lag from your primary database. So let me show you with an example. In this example, you can see that I have my primary in Ohio region, and my two secondary regions are in Northern Virginia and Ireland. My application is writing to my primary database in Ohio region, and let's just say that I want to set global database RPO parameter to 20 seconds. So what does that mean? That means that global database is going to ensure that at least one of my secondary region is within the range of this defined RPO. That is 20 seconds what I will set. So what happens if it is not? Let's find out. So the first scenario is that both the secondary regions have a lag of 0.4 seconds, and it is business as usual, no changes. Now, due to some event, the lag in the Northern Virginia goes up to 22 seconds. However, Ireland is still in the range with a lag of only 5 seconds. So primary thinks it is still okay to carry on the business as usual because I at least have one good candidate across the region to fall back on in case of a disaster. So let's take it up a notch. And now the lag on the Ireland 2 goes up to 21 seconds. And that's when primary thinks that this is a problem. I cannot operate anymore. And it controls the situation by blocking transactions from committing on the primary until at least one of the secondary database catches up and gets under the target RPO of 20 seconds. So to make it clear, the read-only workloads, the reports will still continue, but any attempt to make any changes will certainly be paused. And managed RPO will allow transactions to start processing again on the primary node when any of the secondary is within the range of your defined RPO. So as soon as my Ireland region comes into the 15-second range, it goes green again. And so the trade-off here is that you are giving up the availability of your database to maintain this cross-region synchronization. And there are workloads out there. There are customers and applications who follow very stringent regulations to stay within the compliance of their agreed RPOs across the region. These are mostly financial workloads. These are also the workloads that cannot afford to have stale data of more than few seconds or minutes across the globe. So they would rather take down their service, disallowing their users from making any further changes, rather than having stale data, or rather than having the risk of losing data of more than a few seconds. Again, these customers are mostly financial customers, stock markets, tax application, or it could be any other application, who want a guarantee that they will minimize data loss in the event of a regional failover. And they also have to prove it to their auditors for compliance reasons. All right, the next one I want to talk about, and again, it's an enhancement of global databases, which is managed planned failover. Now, when global databases were launched, you didn't have an option to move the primary region. So the primary region was always the one that you started with. What it meant in case of a disaster, that you would go to the secondary region and you disconnect it from the global database, and now it's your regular primary. However, if you wanted to do, for example, a disaster recovery drill, or let's say you are having performance issues in your primary region and you would like to move your primary to a secondary region, earlier you basically had to first disconnect your global database, make the secondary as your new primary, make sure your application points to the new primary, and then configure global database again. And then it will replicate the data to all over again. So this was obviously a pain, and that's the pain point that global database managed failover addresses. It allows you to say that now I want to move my primary from region A to region B, and Aurora takes care of all the heavy lifting. So how does it work? Let's say I have my same setup again. I have my primary in Ohio, and my secondary regions are Northern Virginia and Ireland again. And the application is running against Ohio in this case. Now, because of some reason, the most common thing again here is that you want to test out your disaster recovery solution, which is again a compliance exercise for a lot of applications and customers. So with global databases, you are simply moving your application over to North Virginia, and in the console you will get an option that failover to the North Virginia. And in this case, we click promote Northern Virginia to be the new primary region. Then Ohio stops for write, and we make sure that we drain Ohio so we never lose any data. And this is all managed for you as it happens in the background without you having to write your own logic or own solution. And then the secondary regions will both catch up to make sure they got all the writes that happened in Ohio. And then Northern Virginia now becomes the new primary. So now it is the primary, and it can accept the write workload. What you as a customer are still responsible for is to point your application to Northern Virginia endpoint, and then you are good to go. So everything here is managed for you outside of your application, and that's why it's called the managed planned failover, which is helping a lot of our customers with their DR testing exercise.
All right, let's take a look at a quick demo for global database. So for this demo, I have my setup here, which I have a global database which has 3 regions: US East 2, EU West 1, and US West 1. The US East 2 is my primary region. It has a writer instance and a read replica. The EU West 1 has a reader instance and it also has a read replica, whereas the third region, US West 1, only has a reader instance. So if I were to add another region to my global database, it is as straightforward as choosing my global database, go to Actions, and say Add AWS region. When you go through this step, when you go through this console of adding a region, it asks you which is the region do you want to add, what should be the instance type, instance size, and then it asks you, do you want to create a replica or do you just want to have a reader in your secondary region? And after that, it ask you the questions about connectivity, about configuration, just as you were creating a new instance, a new Aurora Postgres instance in your estate. And after you make those configuration choices, you simply click on Add Region, and Global Database will create a new instance, a new replica for your primary instance across the region, and it will replicate all the data for you. All right. So we also talked about managed RPO. So how do you implement managed RPO? Managed RPO setting is controlled through parameter groups. So what you need to do is create a custom parameter group, because you of course cannot edit any of the default one. It should be a DB cluster parameter group, and in your parameter group, the DB cluster parameter group, there is a parameter called rds.globalDBRPO, and you can set the value of this parameter anywhere between 20 to this value. And once you have made that change, you simply apply this parameter group to your global database. So if I can show you in my primary instance, under the configuration, you would be able to see that the parameter, the DB cluster parameter group for my primary instance is the prod Aurora PG, the one that we were just looking at. One of the simpler ways of checking what is the managed RPO for your global database is simply running this command. So I'm connected to my primary. This is the writer instance over here. As you can see, the name AWS Summit PG instance 1 US East 2B, and this is the reader instance in my primary region, the US Summit PG instance 1. I'm also connected to the secondary region that is in my EU West. I'm also connected to that instance, and I can run my this command from the secondary region as well. So what I'm going to do here now is that I'm going to run an update statement from my primary instance, from my writer instance, and that is going to generate some load on the database, and we will see that how global databases react to that load. At the same time, while the update statement is running on my writer instance, from my secondary region, that is EU West, I'm also going to run a select statement that is reading the exact same table, and it will be reading the price column, which is being changing, and we will see that the value of this total column changes with every execution. All right, so that means my changes are going through. Now, how do I monitor my global instances? So the number one thing that I'm concerned about is lag. So I go to my EU West, my secondary region, and I go to the obviously it is going to change the region for in the console. It's going to change it to the Ireland region, and I can simply go to the monitoring tab, and under the monitoring there are a couple of additional CloudWatch metrics that can help me with monitoring the global databases. So one of the most helpful one, I would say, is Aurora Global DB replication lag. As you can see that this graph shows me that what has been the lag. So this value is in milliseconds, and the lag is somewhere, it is updating millions of tables right now. It is scanning millions of tables, and you can see that the lag is between the range of 1000 milliseconds to 1200 milliseconds. Another way to monitor your global database status is also by running this command, and I can run it from the reader of my primary region. And by running this command, I can see that in each region, which is the highest LSN written, and what is the RPO lag, and what is the durability lag. So what is the latency in every region. So this command is also very helpful. All right. So hope you have an idea of how global databases work and what the interface looks like.
So in this session, we looked at how you can leverage global databases to your advantage for a highly resilient disaster recovery for your databases. You joined AWS Summit to learn, and you can keep learning beyond the summit with the resources from AWS Training and Certification for Databases. For more information, visit the aws.training/databases and look for the AWS Ramp-Up Guide to create your own learning journey. So I hope you enjoyed the session and learned about the global databases and the use cases and how you can put it to use in your infrastructure. Please take some time to fill the survey for this session because it helps us understand the value of these sessions and plan more curated sessions for you in the future. Thank you.